For the option topic, we're going to do option D, astrophysics, and the first subtopic is D.1 Stellar quantities. When we're looking at stellar quantities, we need to be a little bit clearer about what it is that we're talking about, and so to make sense of some of the concepts that we'll be dealing with throughout this unit, we're going to first of all start off by looking at objects in the universe. Now, some of these definitions are a little bit, they're not necessarily hard and fast, and so we're just going to use some explanations to sort of distinguish between some of these objects. Now, the first one that we're going to deal with is a planet. Now, as we'll jot this down, there's a few things that are particular about planets, and I should mention here that this definition is about basically just about our solar system. So if you start to look outside our solar system, it's not quite as clear. So this definition relates to our solar system, and there's a few things about it that they're still up for debate, and we'll talk about some of those as we go through. So the first thing is that it's an object that orbits the Sun. It's not a satellite of another object, so it's not something that revolves around some other object. It's massive enough, and by massive enough we really mean that it has a large mass. So it's massive enough that its own gravity forces it to be round, so that its gravitational pull makes it round. And the last one that is a little bit contentious in some ways is that it has cleared its neighbourhood. And what that means is that any of the other objects that might be in and around it, it's basically it's sort of dragged them in or caused them to move to a higher orbit. So you've basically only just got the planet there, and so cleared its neighbourhood of smaller objects around the orbit. So that's the definition that basically ruled out Pluto as being a planet, and so the reason why we now have 8 planets in our solar system, and it's like I say, there's a few aspects to it. It orbits the Sun, not a satellite, massive enough that its own gravitational pull makes it round, and cleared its neighbourhood of smaller objects in and around its orbit. So the examples you can see there being the Earth and Jupiter. Now, as we go through, I'm going to use some examples so that we've got a bit of a sort of tie into the some of the objects that you might be familiar with. You'll notice first of all here that the size of the images here that I've got, they're obviously not to scale, considering that the Earth is significantly smaller than Jupiter, and Jupiter has the volume of about 1,300 times Earth's volume. So you'll notice that the scale of things that we're dealing with here will be a little bit difficult to deal with, but we'll talk about that in a later video when we start to look at astronomical distances. So there's planets. The next one that obviously, well, not obviously, but follows on from that is something that's a moon. Now, a moon is a natural satellite, so it's something that has formed naturally. It isn't something that, I mean, we've got artificial satellites that we put up in orbit around Earth, but a moon is a natural satellite that orbits a planet. So anything that is in orbit around a planet that's a natural satellite, we would say that it's a moon. Could also orbit a dwarf planet. So Pluto has a moon, or it could even orbit a minor planet. So a minor planet is being something that's smaller than a dwarf planet. And so a couple of examples there again. So you can see there on the left is our moon, and on the right is a moon of Mars, Deimos. Now, if you look at those two images again, the size of these two, it kind of looks like they're somewhat similar. It turns out that the moon is actually 280 times larger than Deimos. So Deimos is only about 6.2 kilometres across, so fairly small, and so obviously the moon being significantly larger than that. Now we've got planets and we've got moons, and then we've kind of got everything else that's left over, and we're going to group those into small solar system bodies. So that's a term that's used to basically describe anything else that's left. So a small solar system body is basically all other objects. We'll see though that we're going to break them up into a couple of smaller subcategories. So all other objects except satellites. So we're not counting moons in these because moons are orbiting planets. Any other object that orbits the Sun. Now there are two in particular that we're going to identify here. And again, these definitions are not really sort of hard and fast definitions. So if you go and sort of look them up, you'll find that the explanations will vary depending on which source you look at. So we're going to first of all look at asteroids that are sometimes otherwise known as minor planets. Now, an asteroid is basically the easiest way to describe it. It seems a little bit of a cop-out explanation or definition. It's an object that orbits the Sun, but is not a planet or a comet. So that basically just means anything else that isn't a planet or a comet, we would call it an asteroid or a minor planet. Now, before we talk about what a comet is, again, let's have a look at a couple of examples of asteroids. So on the left here we have Ceres. That's the largest asteroid in our solar system. Notice that it does look pretty round, so you might sort of look at it and think, well, why isn't it a planet? If we go back to the planet definition, while it is round, it has a gravity large enough that it forces it to form a round shape. It hasn't actually cleared its neighbourhood of smaller objects around its orbit because it exists in the asteroid belt. So it's not a planet for that particular reason, so it's a minor planet. The one on the right is, I'm not sure if I'm going to pronounce this correctly, but I'll give it a go, is Ryugu. It's an asteroid that the Japanese recently landed on just earlier this year. That's only 870 metres across, so you can see there that quite small in comparison to Ceres, which is it's about a quarter of the size of our moon, Ceres. So Ryugu, only about 870 metres across, is a fair bit smaller. Now, most of these asteroids are found between Mars and Jupiter's orbits. Quite often they're irregular in shape, because their gravity is too weak to compress it into a sphere. There are some other asteroids in further out past Neptune, but most of the ones that we'll focus on will be in the asteroid belt between Mars and Jupiter. Now, moving on to comets. So we mentioned that asteroids definitely weren't comets, so we need to be very clear about what a comet actually is. And a comet is basically an object containing certain stuff. And that stuff is frozen gases. So the frozen gases is the key thing, and we'll have a look at why that's so critical, about what makes it so critical for a comet to be consisting of frozen gas. Also consists of rock and dust. Now, when you have a comet, or when a comet nears the Sun, what happens in that situation is that the comet heats up, and so the gases vaporize. And that means then if the gases are being vaporized, it produces a coma. Now, a coma is basically just a small atmosphere that's attached to the comet. So it produces a coma, so a small atmosphere, and a tail. And that tail which is always directed away from the Sun. and the reason for that is because of the solar wind that sort of strips off the gases and the dust and the rock and sort of propels it away from the comet. So any observations that you'll see of a comet or any images, the tail will always be directed away from the sun. Now again, a couple more examples. So the one on the left, I'm not even going to bother trying to pronounce it. I'm sure I'll get it wrong, but it's the comet that the European Space Agency sent the Rosetta probe to, and were able to land on it, take some photos while the probe was in orbit as well, and so fairly significant object that we were able to visit. And the other one on the right hand side is Halley's Comet, and you'll notice that there's sort of two very different images of comets here, the one on the left being very much a close-up image. You can't really see the tail all that clearly, you can just sort of see the surface itself, so the rocky surface, whereas for Halley's Comet you can see the tail being projected away from the sun, so the sun would be sort of somewhere down to the right of that image as the Halley's Comet goes moving around the sun itself. The other thing that's worth noting about comets is that they usually have very elliptical orbits, so they swing very close to the sun and then sort of are propelled way out into the far reaches of the solar system before sort of swinging back in again. So the last thing that we need to talk about in terms of objects is basically sort of grouping all of that together. It's a planetary system. Now, a planetary system, as I said, grouping all that stuff together, it's a set of gravitationally bound objects, and that can include planets, asteroids, comets, and so on and so forth. But it's one of the things that's particularly important to note is that they are non-stellar objects. Now, when we say non-stellar, we're basically saying they're not stars, and so they're anything that's not a star that is in orbit around a star. Or a star system. And by star system we basically mean, say, one or two or more stars that are orbiting each other. So our planetary system can be represented in a diagram like that one. We call it the solar system. Note that this is definitely not to scale, so the size of the planets themselves and even the distances from the sun, definitely not to scale. You're very rarely ever going to see a diagram that's to scale that includes both the size of the planets and the size of their orbits. So generally speaking, these sorts of diagrams are just to give you an idea of what the planets are and what the order is, not necessarily how they're related to each other or how far apart they are, those sorts of ideas. So there's the objects in the solar system, and objects in the universe. In the next video we'll start looking at stars and some of the objects that these planetary systems are orbiting.